Hello everyone, I'm Charlotte Scarpa and today I'll be presenting our work on the interaction between vibroacoustic discomfort and visual stimuli, where we compare experiences across real, 3D and 360 environments. This work is part of my PhD research and it is a joint work between the Laboratory of Numerical Science of Nantes University and the Scientific and Technical Center for the Building Industry. So in our first part, to give you a little bit of context and challenges that inspired this research, we lived in a time in which the professional world is constantly evolving and work practices are undergoing significant changes. So also with environmental challenges and the energy renovation of buildings planned in the coming years, it is really important to quantify the impact of the quality of indoor buildings on the comfort and on people. So it is also a unique opportunity to reconsider the design of workspaces. Moreover, recent research has shown the impact of sensory stimuli on well-being, comfort, and productivity, and also an important influence of vision on the perception of environmental information. So on these basics and considering the importance of visual cues, we realized the importance and the potential that we could benefit from immersive technologies to assess indoor environments. So with immersive technologies, we can manipulate environmental parameters easily, also collect physiological and behavioral data while maintaining ecological settings, and also explore more dynamic aspects of sensory perception. So thanks to the potential of VR, we can also answer this following question, which are part of my PhD research, such as how multisensory information is integrated and processes, which environmental parameters most influence perceived comfort and performances, and also how do we carry out sensory evaluation of workspaces. So to really understand how to implement digital technologies to study sensory analysis in the building sector, we built a methodology that allows us to expose participants to sensory information in a simulated environment and collect at the same time physiological data. So in order to validate this methodology and to understand its limits, the first part of the project, which is the research that I'm presenting to you just after the slides, involve a comparison of vibro-acoustic discomfort in 360 and 3D environments to real-life settings. So, you can see here the place in which the study took place. So the participant was sitting on the black chair on the blue vibratory platform, and they were exposed at the same time to acoustic stimuli with the speakers and the subwoofer that you can just see it on the bottom middle, and to vibratory stimuli on the vibratory platform. Vibroacoustic stimuli that we use were conceived from original recordings of a train passing by a building situated close to a railway line, and these recordings were then modified to enhance or diminish certain aspects of vibroacoustic stimuli, and such as physical vibration or airborne noise. And you can see here the stimuli were 9, and and for the environment we recreated our lab in 360 by taking a 360 photo from the point of view of the participant, of the viewer, and adapting it using Unity. And for the 3D, we recreated all the room in 3D by using just means that are accessible to everyone, and we used the Pico 4 headset. All through the test, we recorded participants' physiology measures such as heart rate, electrothermal activity, cutaneous microcirculation, respiratory rate. All of all of this of this data indicating different states such as awakening or relaxation, stress, enjoyment. And you can see from the picture the captors that we used. So we did different questionnaires to understand subjective states. There was the emotional states, the visual perception questionnaire, in which we asked people how they were feeling in the space and if they liked the space. And then for the vibroacoustic stimuli, we used two questions, which was one, the first one, it was how noticeable was the noise, vibration, or both. And the second one was how annoying was the noise, vibration, and both. And all of these questionnaires comprise the Likert scale. So then we also had a cognitive test, word memory tests, in which you can see it on the screen, in which they had to memorize a set of words and find them among distractors. So for the protocol, it was really important for us that the participants were blind to the environment. So they never saw the environment apart from when it was the participant that tried out the real environment. And so this was the protocol, but don't worry, I'll show you in more detail. So they had 20. They had a first part in which they explored the environment and they answered to the questionnaire, the subjective questionnaire and the visual state questionnaire. And then they had two different parts. The second, in which they heard the sound and or the vibration, and they answered the question on perception and discomfort. And the third part, in which they had the memory test. At the same time of the memory test, they listened to the sound, and then they had the two questions, the one on perception and the one on discomfort of the sound. And so for each of this part, there were nine repetitions. So we used 10 participants for each format, and each subject tested a single condition, either real at 360 or 3D. So here are the results for the subjective questionnaires. So there weren't a major difference across environment apart for the emotional state, in which we realized that 3D elicits stronger emotional response than 360, despite if we go and look at the visual comfort, we can see that 3D has less visual comfort, but for more emotional arousal, we can see. Then for the discomfort to vibroacoustic signals, so we counted the number of signal pairs that showed significant differences, and then we looked at how many significant differences were for only sounds and the sounds plus memory tests, and we can see that when there are only sounds, in all environments, participants discriminate good, and there weren't significant difference. And we see that when we put the memory tests, participants have more difficulty discriminating the pairs apart from 3D, which is easier for them. We can see that the mean discomfort to vibroacoustic stimuli in interaction with memory tests is a little bit higher in the real environment, and also yes, so we see that there is a degraded discriminability observed with cognitive tests in all conditions and better pair in the 3D conditions. When we go and look for a score and discomfort rating, we saw a good correlation between score and discomfort in virtual condition, and in the real environment we have a slight trend, but that is not significant. Finally, we looked at PICT analysis, EDA PICT analysis, and we realized something quite interesting is that EDA signal was quite different in simulated environments. It presented more peaks for a lower amplitude. So overall, this study serves as a preliminary exploration aiming to test the feasibility of the research design and identify initial trends. So it allows for initial assessment of the differences between real and simulated environments, and also offers a fundamental understanding that can guide more extensive research on ecology and validity of simulated environment, discomfort, discriminability of vibroacoustic signals, and cognitive indicators of discomfort, and with also a special attention when working with EDA signal.